Okay, we talked yesterday, a couple days ago, about finding slope by the rise over run, but we're going to take a step back and we're going to start putting all of our stuff together for linear equations. So we're going to talk about a family, and we're going to put our family in context because I know you're asking yourself now, when are we going to ever do this? It's just lines and graphs. This is why you are to use it. Here's our family. It's a family of the future. We have the dad. His name is George. George has a job. He makes $20 an hour. Now we're going to give some of these topics letters. So the amount of money George makes, we're going to call it the Y. And the amount of hours he works, we're going to call it the X. So George makes 20 bucks an hour. Jane, his wife, makes $40 an hour. Jane, his wife, makes $40 an hour. Okay, same, but we're going to use the same letters. Y is going to stand for how much money Jane makes, and X is going to stand for how many hours Jane has to work. So for now, we're just doing George and Jane talking about their jobs. And of course, now we want to put it on a graph, or we're going to somehow look and see, who makes more money and how much, and a lot of different things that we can figure out. So if George makes 20 bucks an hour, if George worked for 0 hours, how much money would he make? Pretty simple. He would make $0. So if George worked for 0 hours, he would make $0. And our letters that we have happen to be X is the hours worked. He worked 0 hours. Y is he makes 0 money. If George got motivated one day, though, and he decided to work for 3 hours, how much money would George make if he worked for 3 hours? And you can figure that out. It would be $60. So George, if he worked for 3 hours, he would have $60. The same X and Y. He works for 3 hours, which is X. The money is $60, which is Y. Jane, his wife, who is a much harder worker and has a much better job, she makes 40 bucks an hour. So Jane, if she was to work for 1 hour, now of course she would make $40. And if Jane were to work for, I don't know, let's say she worked 2 hours, she would get $80. So again, the same letters work for both people. George is $20 per hour. If he worked for 3 hours, he'd get 60 bucks. If he worked for 5 hours, he'd have $100. So that is what they make there. Jane, of course, $40 every hour. 2 hours is 80. We could go on. 3 hours is 120, etc., etc. So let's put all this on a graph. How would that look if we put it on a graph? So let's look at, let's take care of George. George is the blue line. If you are 0 and 0, so since we've given letters already to George's how many hours he works and how much money he gets, we can put it on a graph. We can put the 0 hours and 0 money right down there, and we could put the 3 hours of work and $60 right there at 3 and 60. So the blue line's already made. So let me get to the blue line. We're just going to move this right over here. And there's George's graph right there. That graph shows how much money George will make depending upon how many hours he works. If he works for 1 hour, it'll be $20. 2 hours is $40. 3 hours is $60. 4 hours is $80, and he can work as long as he wants. Jane, on the other hand, she works for 1 hour, it's $40. I put her point right there. If she works for 2 hours, did I say one? I meant 1 hour. 1 hour for $40. If Jane works for 2 hours, she has $80. She's the green line, so we put Jane's green line right there. And there's the graph of Jane, which represents how much money Jane makes depending upon the amount of hours she works. So now we can start talking about slope with a little bit more meaning than just random lines. Look at the 2 lines. Jane's line is the green one. George's line is the blue one. Which one has the steeper slope? And you're right. If you're guessing, well, the steeper one's going to be Jane, and that's correct. Jane's slope is steeper. If we were to measure the slope, because we did rise over run recently, how would you do that? Because we taught you how to do that. Here's a pre-made rise over run for Jane. And here's a pre-made rise over run for George. Right there. So let's go ahead and count George's like we did before. We rise over run. So this is the rise. So we're going to count that. Now, this is one thing we did not talk about during the lesson. This scale is not going by ones, it's going by tens. So as I count up here, I'm going to count by 10. 10, 20, 30, 40, 50, 60. That has a run of 60. A rise of 60. Let me pause this so I can type these letters. Hold on a second. This has a rise of 60. This has a run of 3. So I want to stop and do one thing. So we're counting George's, how much money he made on the rise. And I told you again that these are going increments of 10 now. We counted up from 10, 20, 30, 40, 50, 60 is the rise. His run is in hours. 1, 2, 3. I put the 3 down here. So rise over run is 60 over 3. And you can simplify that to 20. Okay, it is not a coincidence that the slope of 20s, George's slope is 20, happens to be how much he makes per hour. That's not a coincidence. We'll get to that as we talk more about our family of the future. Jane makes $40. Her rise and run is 40. There's the 40. That's 10, 20, 30, 40. That is a 1 over there. 40 over 1 is the slope for Jane using rise and run, which equals 40. And it is not a coincidence that Jane's slope of 40 happens to be the amount of money she makes per hour. So this is why we do slopes, so we can look at these numbers and arrange them. And we're going to stop there for this first installment of the family of the future and how slope and linear equations can help us figure out how much money they make.